Good morning to all. Myself, Dr.R.REKA, Assistant Professor, Department of Statistics, Sri Sharada College for Women, Salem. Now I'm going to talk about probability theory. Probability theory does nothing but it is a measure of the likelihood of an event to occur. Many events cannot be predicted with total certainty. We can predict only the chance of an event to occur. That is, how likely they are going to happen using it. So it is the probability theory. Next one, random variable, which is the important concept of probability theory. The definition of random variable is it is nothing but it is a function whose domain is the set of possible outcomes and whose range is a set of is a subset of the set of reals. Such a function is called a random variable. It is usually denoted by the capital letters, capital letter X and capital letter Y. This is the example of random variable. Suppose that a coin is tossed twice, so that the sample space is um, head and head, head and tail, tail and head, tail and tail. So which is denoted as S, that is sample space. Here, X represent the number of heads that can come up. With each sample point, we can associate a number for X, which is shown in the following table. Here, in the case of HH, which means that two heads, that is X equal to 2. While for TH, that is tail and head. So here one head. So X is equal to 1. It follows that X is random variable. That is sample point is head and head, head and tail and head, tail and tail. So the sample point is 2, 1, 1, 0. So this is the example of random variable. There are the following types of random variables. First one is discrete random variable and second one is continuous random variable. A discrete variable, it is nothing but it is a random variable which takes on a finite or countably infinite number of values is called a discrete random variable. Example of discrete random variable. First example, a mark obtained in a test and a number of accidents per month and number of telephone calls per unit and number of success in end trials. So which is the example of discrete random variables. This is the example problem of discrete random variable. A random variable X has the following probability function, and here we have to find out the k and evaluate probability of x less than 6, comma probability of x greater than or equal to 6 and probability of 0 less than x less than 5. First, we have to find out the sum of p of x, which is equal to 1. Here, p of x is 0, k, 2k, 2k, 3k, k square and 2k square and 7k square plus k. So these are the given probability function. So here we add um, all probability functions, that is k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k, which is equal to 1. Just we simplify that, we can get k is equal to 1 by 10 or k is equal to minus 1. But here p of x cannot be negative. So k is equal to minus 1 is rejected. So hence we can take the value of k is 1 by 10. So next one, we have to find out the probability of x less than 6. Here we have to take the values 0, 1, 2, 3, 4 and 5. That is, probability of x less than 6 is equal to probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4 plus probability of x equal to 5. Here the values of probability of x equal to 0 and probability of x equal to 1, which is equal to k. So already we have the values of k. So k is equal to 1 by 10. Just to substitute this value here. So next one, probability of x equal to 2, which is equal to 2k. So already we find the value of k. So 2 into 1 by 10, 2 by 10. Next one, probability of x equal to 3, which is equal to 2k. So 2 into 1 by 10, which is equal to 2 by 10. Next one, probability of x equal to 4, which is equal to 3k. So 3 into 1 by 10, 3 by 10. Next one, probability of x equal to 5, which is equal to k square. So already we know the k value, that is 1 by 10. So k square means 1 by 10 the whole square, which is equal to 1 by 100. So just we simplify this one, we get 81 divided by 100. Then we have to find out the probability of x greater than or equal to 6. So which is equal to 1 minus probability of x less than 6. So this is the base formula. So here already we find out the probability of x less than 6, which is equal to 81 by 100. So just to substitute this value here. So 1 minus probability of x less than 6, which is equal to 1 minus 81 divided by 100. So just to simplify this, we can get 19 divided by 100. So next one, we have to find out the probability of 0 less than x less than 5. So which is equal to probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4. Here we have to take the values in between 0 and 5. So in between value is 1, 2, 3 and 4. So already we know probability of x equal to 1 value is k. So k is equal to 1 by 10. So otherwise we go to another method, just to substitute the table value here. That is, the given problem is probability of x equal to 1, which is equal to k, and the probability of x is equal to 2, which is equal to 2k, and the probability of x equal to 3, which is equal to 2k, and probability of x equal to 4 value is 3k. Just we add these four values, that is k plus 2k plus 2k plus 3k, which is equal to 8k. So then we substitute k values here. So 8 divided by 10, that is 8 into 1 by 10, which is equal to 4 divided by 5. So the value of probability of 0 less than x less than 5 is equal to 4 by 5. Next one, continuous random variable, which is a continuous random variable is nothing but it is a random variable x is said to be continuous if it can take all the possible values between the certain limits. A continuous random variable, which is a random variable that can be measured to any desired degree of accuracy. So this is the continuous random variable. For example, age, height, and weight are the example of continuous random variable. Next one, problem for continuous random variable. For example, the diameter of an electric cable, say x, is assumed to be a continuous random variable with PDF. F of x is equal to 6x into 1 minus x, comma 0 less than or equal to x less than or equal to 1. So first one, we check that f of x is PDF, and second one, determine a number b such that probability of x less than b equal to probability of x greater than b. So solution, here given the limit of x is 0 to 1, that is 0 less than or equal to x less than or equal to 1, and f of x which is greater than or equal to 0. So now we check that the given f of x is PDF. So here we have, that is we have to prove that integration 0 to 1 f of x dx equal to 1. So just we substitute f of x values here. So integration 0 to 1, 6x into 1 minus x into dx. So just we have to simplify this. We can get the answer is 1. So that is 6 into integration 0 to 1 x into 1 minus x into dx, which is equal to 6 into integration 0 to 1 x into 1, which is equal to x minus x into x square into dx. So then here we have to take the integration. So uh, we have to integrate x into dx. Just we can get x square by 2 minus integration x square dx, which is x cube divided by 3. Then we have to substitute the limit, that is upper limit minus lower limit. So we can get the answer is 1. So given f of x is the PDF of, that is probability density function of random variable x. Next one, second one, we have to determine a number b such that probability of x less than b, which is equal to probability of x greater than b. Uh, Here integration f of x dx, just limit, upper limit is b and lower limit is 0, which is equal to integration f of x into dx. Here upper limit is 1 and lower limit is b. So just we can substitute f of x here. So integration 0 to b, 6x into 1 minus x into dx, which is equal to 6 into integration x into 1 minus x into dx. So here we have to take the integration of both sides. Um, so we can get x square by 2 minus x cube by 3. The upper limit is b and the lower limit is 0, which is equal to x square by 2 minus x cube by 3. The upper limit is 1 and the lower limit is b. Just we can substitute both upper limit and lower limit here. That is upper limit b square by 2 minus b cube by 3 minus lower limit, which is 0. Next equal to the upper limit is 1, so 1 square divided by 2 minus 1 cube by 3 minus the lower limit is b square by 2 minus b cube by 3. Here 3b square minus 2b cube is equal to 1 minus 3b square plus 2b cube. So just we simplify this equation. We can get 4b cube minus 6b square plus 1, which is equal to 0. So it can be written as 2b minus 1 into 2b square minus 2b minus 1, which is equal to 0. Then we can simplify that, that is 2b minus 1 is equal to 0, and after that 2b square minus 2b minus 1 is equal to 0. So here 2b minus 1 is equal to 0, so we can get b is equal to 1 by 2. And another solution, 2b square minus 2b minus 1 is equal to 0. So we can simplify this one. We can use the formula minus b plus or minus square root of b square minus 4ac divided by 2a. So here b value is minus 2 and a value is 2 and c value is 1. So just to substitute these values in the formula minus b plus or minus square root of b square minus 4ac divided by 2a. So we can get 2 plus or minus square root of 2 square, that is 4, minus 4 into 2 into minus 1, which is equal to plus 8, divided by 2a, 2 into 4, 2 into 2, which is equal to 4. So finally we get 2 plus or minus square root of 4 plus 8, that is 12, divided by 4. So next one, we have to take the root, that is square root of 12. We can write 2 into square root of 3. So 2 plus or minus 2 into square root of 3 divided by 4. Then we can get 1 plus or minus square root of 3 divided by 2. So here we can take d value is 1 by 2 because it is only real value lying between 0 and 1. So this is my reference book. Thank you.